Hi, everybody. I thought I would spend a little bit of time going through the script that we started in class a couple weeks ago. And then this video is also available for people who might want to follow along who aren't in the class. So this is a simulation script that basically just shows how to do a calculation of extinction probability with some simple parameters. So the very simplest of all simulation calculations. That it's a little more complicated than just, a one-shot event. So what we'll imagine is we have some time frame, say in this case, 1,000 years, and every year there's some probability of extinction, and these probabilities are all independent. So this year something can happen, we go extinct. Next year something can happen, we go extinct. We'll assume the probability is the same every year and that it's always independent. So if we didn't go extinct this year, it doesn't change the probability of going extinct next year. Obviously, if we go extinct this year, there isn't any reason to calculate a probability of going extinct next year because we're already extinct. Um, so we'll imagine we have 1,000 years. We'll imagine an annual probability of going extinct. And we're going to do a simulation that replicates this 1,000 times. So basically, for each one of the 1,000 years, we'll draw from an urn with 1,000 black balls and one red ball, 999 black balls and one red ball. That would be 1 in 1,000 probability. This is actually 1 in 10,000. So 10,000 balls, 9,999 are black and one is red. That'll be our extinction. So we'll imagine each year we draw from the urn with replacement. So whatever, balls, same probability every year. Um, and we'll calculate over the course of 1,000 years. Maybe we go extinct, maybe we don't. And then we'll do that 1,000 times. So we'll replicate it 1,000 times. So we'll do 1,000 simulations and then calculate the average of how many times did we go extinct? How many times did we go extinct in year 632? How many times did we go extinct in year 47? How many times did we go extinct in year 984? So we'll calculate that. We could simulate this 10,000 times, 20,000 times, 50,000 times. Since it's probability is pretty straightforward, the simulations are generally going to give very close answers. We can also calculate the analytical, how often we're likely to go extinct, and that's just one minus the probability that we don't go extinct. So the probability that we do go extinct is one minus the probability that we don't go extinct. If the probability is that we do go extinct is 0.001, 0.0001, the probability that we don't go extinct is 0.9999, right? Yeah. So the probability that we don't go extinct uh, over each year in 1,000 years. So over that 1,000 years is just 0.9999 raised to the power 1,000. It's 0.9999 times 0.9999 times 0.9999. Um, and so that's what we'll calculate here. We'll see in a second. This cumulative probability will give us the syntax here will give us a vector, the cumulative probability that we don't go extinct after 1 year, which is just 0.9999, after 2 years, which is 0.9999 times 0.9999, the probability that we don't go extinct after 3 years, 0.9999 times 0.9999 times 0.9999, turns into a tongue twister. So that's this syntax here. We calculate this for the sequence of 1 through 1,000. So first, let's set our parameters here. So we have them now here, 0.001, 1,000, and 1,000. We'll calculate this cumulative analytic probability. So there we have it. See, it's a vector of 1,000 things. The first one is 0.001. The second one is, um, this is, yeah, it's the probability that we go extinct, right? It's 0.001, 0.0, Yeah. Um, and so that's our probability that we're going to go extinct. Um, and then we're going to now simulate it. So we're going to set a seed. We're going to replicate our simulation 1,000 times. So n simulations is 1,000. I think that was here someplace. Yeah, there it is, 1,000. For each population, we're going to find the year that they go extinct. So if we run this once, for example, I think if we run this once, it will look like this. Extinct year. Oh, because we didn't go extinct at any time. We can keep running this, and eventually we will get. Oh, did we? I didn't catch it there. I'm clicking each time I'm running it, and eventually we'll hit a year that we will go extinct, and that'll be the year that we um, draw, bad luck from that year. So we're drawing from a uniform distribution. We're drawing 1,000. Uh, what's the when we look at this, we see here's the 1,000 draws from the uniform distribution. If one of them happens to be less than 0.001, we'll say that's the year we went extinct. Um, so we draw a bad luck outcome. So we can see for this one, it's close, but not less. Let's see if there was any in this series. We need basically three zeros, right? Four zeros, some outcome with four zeros. Very, very unlikely, right? That in the interval 0 to 1, we would draw a number 0.00001. But let's see. Yeah, well, we don't. The whole point of the script is it will calculate this, so we'll run it 1,000 times. If we don't go extinct, we're going to use the special R number called a term called infinity, which means we're not going extinct in any year. Let's run this 1,000 times. Actually, yeah, let's go ahead and do this, and we'll see we have now something called simulation results. And we can dump this down in the console. And so we see, oh, we went extinct in year 957, this simulation, in year 567, in this simulation, in year 619, in this simulation, in year 62, in this simulation. So there are years when we go extinct, but most years we don't go extinct. So that's our simulation. We can do a histogram. We're going to rename, do a little bit of cleanup here, and then a little bit of cleanup there, and there's our ggplot. The What I did here was recode if we don't go extinct. I recoded that to be 1,010 here. So we see that most times we don't go extinct, but there are a few times years that we do go extinct on this histogram. And now we can calculate the cumulative probability for each year, the probability that we go extinct before that year, and we'll gather this into a data frame, and then we get our graph of these probabilities. And I assigned it to this object cumulative risk graph, so I'll run it now. And there we go. So we have the years 0 through 1,000. Um, the analytic solution is about a 9% chance that we will go extinct after 1,000 years. So this red line is just that cumulative probability of going extinct in a year. It was this one, I believe. Zero point zero 0.01 the first time, 0.02, 0.03, just rises linearly as we go along. With the simulation, we see it varies a little bit because good luck, bad luck. Sometimes we go extinct, sometimes we don't. It's not going to be exactly the same as the analytic solution. The more uh, simulations we do, so if we did 10,000 simulations, we'll see it'll get very close. Well, I'm going to skip the histogram here. Let me just put hashtags in front of the histogram. And then we can run this So that's going to go 10,000 times. Now we see, right, it got very close. If we just did it 50 times, then we're going to be fairly different from the um, cumulative thing, right? There we see that depending on our good luck, bad luck, if we change the seed, so we change the seed, so now we'll draw different random numbers, we'll end up with a different pattern here, right? And there we go, we have a different pattern where we go extinct a lot more in this particular simulation. That's why we do many simulations to average over each one of these simulations instead of doing just 50 simulations. More than that, So we have a little bit here about what's the expected value of going extinct under some reasonable assumption about what the cost is of going extinct. And that's a guide to how much might want to pay to prevent going extinct. So the best way to understand the script is to play with it and run it and let me know what you think.